Then fourfold axis of symmetry, if you want an example, xenon tetrafluoride, it's a square planar. So square planar, when we see, so axis is made to pass through xenon. So here the axis is made to pass through xenon like this, which is perpendicular to the plane. So when it is passing through this, what are the possible angle of rotations to get an indistinguishable configuration? So we could see the angle between these two will be what? 90 degree. So when the rotation is done through 90 degree, then what is that? We get indistinguishable configuration. We could see this fluorine will change to this position. This fluorine goes here and this will come here and this goes like this. So we get an indistinguishable configuration. So it is done one time, first time. So C4, 1. So C4, 4, how do you get? 360 divided by, through what angle it is rotated? 90. Then N is equal to 4. So it is fourfold axis of symmetry. Then let us see how many fourfold axis of symmetry are resulting out. So one time it is being rotated. Again, the second time it is being rotated. We get an indistinguishable configuration. Third time it is being rotated. Again, we get an indistinguishable configuration. Then when it is going for the fourth time, so 4 into 360, 4 into 90, what do you get? It will be 360. 4 into 90, then we get 360. So 360, which says this configuration and this configuration, the initial one, are same. There is no any difference. Hence we could conclude C4 4 is actually leading to the original configuration. Then it should be represented as identity element. Then one more observation. What is that? The same, through the same axis, if the rotation is performed through 180 degree. What is that 180 degree? So here the angle, it is 180. So when the rotation is performed through 180, then this fluorine takes up the position of this one, and this fluorine will take the position of red. Similarly, this yellow fluorine and green fluorine gets exchanged. So 180-degree rotation is being done. So here this 180-degree rotation, here it is done. So it is one time it is done, C2 1. So you could observe one interesting factor, that 90-degree here, okay, plus one more 90-degree. When it is done, what is the configuration you obtained? This is the one. So can you see this configuration? Okay, then this configuration, are they same or not? Yes, they are same. So when we are performing 2 times of 90-degree, then we get this configuration. The same thing is got when we performed 180-degree configuration at once. So you could say that this C21, that is 180-degree rotation, which has been performed, which is equivalent to C42. C42 means 90 plus 90. So instead of writing this C42, we could write C21. Understand? Similarly, again one more time, C22 is being performed. So this C22, it is just similar to that of the original configuration. So first one, you could see that. So this original configuration, whatever we got here, and the last C44 here, all are same. So C22, C44 are same, and then they are supposed to be equivalent to what? E. So you could summarize, okay, here we get C41, okay, it's a unique. C42, it's we are getting, and that C42 actually can be represented as C21. So C2 is present in this C4, C42. So C21. Then C43, it's again a different unique. Then C44, which is equivalent to what? C22, which is actually equivalent to what? E. So we could summarize, it should be equivalent to E. How many unique C4s are there? This is the one, and this is the one. So there are two C4s, then 1 C2, this one, and we have E. That is what we have written. So totally E, 2 C4s, and then 1 C2. So this is with respect to the rotational axis perpendicular to the plane of the molecule passing through xenon atom. Then we have to see other possibilities of rotation by placing the axis in the plane of the molecule. Okay, if we are placing the axis in the plane of the molecule passing through xenon atom alone, then it is actually passing through the edges. Okay, center of the edges, two edges it is passing through, and through xenon atom it is passing. So here the rotation is made in such a way that we get indistinguishable configuration. So 180-degree rotation, if it is done, this goes here, this comes here. So like that, this will be going here and this comes here. So it is being changed here. So C2 prime. Again, another possibility is that, so the same axis in the plane passing through the center of other two parallel edges, okay, through xenon. 180-degree rotation is made. Then we get this, this two gets interchanged. Okay, this two gets changed. So C2 dash, C2 prime, another C2 prime. So 2 C2 prime we have. So the axis again in the plane, it is passing one more possibility through xenon, and it is passing through the corner atoms, opposite corner atoms. If it is passing through opposite corner atoms, then the rotation is made with respect to this through 180-degree rotation, through 180-degree rotation. So what will happen, students, here? This fluorine, which is where the axis is passing through, doesn't change. So red color fluorine doesn't change. This pink color fluorine doesn't change, and xenon doesn't change. Only this fluorine gets interchanged with that of the this fluorine. Okay, so flipping. So this is another kind of rotational axis. The rotational axis, rotation, where the rotational axis is passing through three atoms, okay, in the plane. Similarly, two corner atoms, a set of corner atoms, and one more set of corner atoms through which the rotational axis passes through. So we have another C2 prime. So there are two C2 prime. So this C2 prime and C2 double prime, it is actually resulting when the axis is containing in the plane of the molecule. So when we are summarizing for xenon tetrafluoride, so when the molecular axis is passing perpendicular to the plane, we have E comma 2C4. We have seen that this is the one and this is the one, and C2, which is there in C4 itself. So C2, then E. E is what we have written here. Then when the rotational axis is right angle to C4 rotational axis. This is again one more way of explaining the axis in the plane. So the axis is in the plane, which is again perpendicular to the C4 axis. So this is C4 axis, which we are saying perpendicular to the molecular plane, like this C4 axis. Now what you say? You are saying the an axis which is actually in the plane, it is containing in the plane. If I want to represent the perpendicular axis, let me put it in the dotted line so that it will be easy for you to visualize. So this is how I am representing the dotted line perpendicular to the plane. Okay, like that. Now when I see the difference between this two and this two, this is perpendicular and this is containing in the plane, just kept on the plane. If it is kept on the plane, this is this one, it is perpendicular to this one. So that is what it is written. So for C2 rotational axis, they are right angle to C4 rotational axis. They are right angle. So here, these are all right angle to the rotational axis. So in that, how many are there? 2 C2 prime and 2C2 double prime. So all are put together, which will be resulting into 2C4 C2. So this blue color, why I am representing, it is actually which is actually perpendicular axis, which is in the C4. Okay, C2 is along with the C4. Then these 4 C2s where the rotational axis are in the plane. Then E. So this is how we get the various symmetry, proper axis of symmetry elements for the molecules. Possible ways. Okay, so here is the 5-fold axis of symmetry: cyclopentadienyl anion C5H5. It's a negatively charged, it's an anion. Now C51 is performed, C52 is performed, C53, C54, C55. Okay, so in this case all the C5s are unique, it cannot be equated to other. Okay, C5 2. Okay, so what is that? C5, C5 360 degree divided by 5. So what do you get? Through what angle it is being rotated, students? So 35, so 1, 10, 72. So it is rotated through 72 degrees. So no other rotations will make in order to get any other. So C51, C52, C53 are all unique. How many then? 4 C5s you could say. Then as usual, according to the rule, C55 complete 360-degree rotation, then it represents E. So that is what E it is written. Apart from that, the rotational axis being perpendicular to the molecular plane, apart from that, you could also see the rotational axis in the plane of the molecule. How in the plane of the molecule? So it is passing through carbon and hydrogen, and it is bisecting the center of the edge. So like that, how many centers you have? This is 1, 2, 3, 4, and 5. So 5 C2s are possible. So that is what here it is represented. So for cyclopentadienyl anion E, okay, identity element, 4 C5s and 5 C2s, proper axis of symmetry elements are present. Then 6-fold axis of symmetry, here we could say C61, okay, it is performed 6 360 360 by 6. So what is the angle? 60 degree. So reverse also you could say, what is the angle between carbon? So this is the benzene, this is benzene. So angle, it is nothing but angle between two carbons, it will be 60. Okay, so 360 divided by 360 divided by 60 degree, so it will be 6. So it is represented as C6-fold axis of symmetry. So like that, C61 is performed. Okay, C61. Then C62 is performed. So C62 means 60 plus 60, 60 plus 60, it is equivalent to what? 120. So how do you represent 120? 120 is represented as C31. Okay, so C62 is nothing but C31, means C62, when you are performing the rotation, it gives the configuration as though similar to that of the C31. So we can equate C62 to C63. So C3, this C31 is actually in the C62, in C6. So we have to take like that. Then C63. So what is that C63? 3 times of 60 degree. So 3 times of 60 degree, what is that? 180. 180 is nothing but C2. So C2, 1. So 360 degree means C6, 3 times is equivalent to what? 180 degree, 1 time, C2, 1. So here, C2, 1, which is equivalent to that of C63. Then comes C64. C64, it is equivalent to C32. So you could also see 2 by dividing 4 by 2, 2 again 2, 6 is divided by 2, so common we divide by 2, then we get C2 3, both are same. And C6 5 is unique, then C6 6, obviously it should be equivalent to what? Identity. So when you are putting together E, we are getting okay. Then how many unique C6 are resulting out? The unique C6 here, it is 1, and here this one, so 2C6. Then the C3, how many? Here is one C3 and this is another C3. So two C3s are present. So this C3 is resulting out that from C6, means whenever axis is perpendicular to the molecular plane, then we get what? This C6. So in that C6 we have this 3, C3 fold axis of symmetry. Then how many C2s from the C6 that they have resulted? This one, C2 1. So this is what it is written. Any other possibility then apart from that? So molecular axis, the rotational axis perpendicular to the plane. And one more possibility, the rotational axis will be in the plane of the molecule in possible ways, so that rotation is done. So what are they? So axis passing through carbon and hydrogen and passing through opposite carbon and hydrogen, means opposite corner atoms. If the axis is passing through, then that is one type of C2, that is C2 double prime. And one more C2 is the axis passing in the plane, um, which is actually passing through centers of the parallel edges, which is passing through the centers of the parallel edges. So this is one edge and this is another edge, parallel edge. When it is passing through centers of the parallel edges, then that also will be resulting into the indistinguishable configuration. So we are representing that. So how many parallel edges we have? So this is the one, then this and this we have, and this and this. So totally 3 parallel edges. So 3 C2 dash. Then how many corner atoms we have? 3 corner atoms you could relate, you could connect. So we have 3 C2 double prime. So it is being summarized here, 3 C2 prime, 3 C2 double prime. So these two are representing in the plane. Up to this one, these are representing perpendicular to the plane. So this is how we can find various symmetry elements, that is rotational axis of symmetry elements for the molecules. Here is another example where 3 two-fold axis of symmetry is present. Always do remember, two means I could say two-fold axis of symmetry is not possible. How it is not possible? C2 one time we are carrying out, okay, then C2 two times we are carrying out second time. If C2 2 is actually equivalent to what? E. So E comma C2. How many C2s then? Only one. There are no two C2s. But here in this molecule, there are 3 two-fold axis of symmetry are possible. How? Then these 3 two-fold axis of symmetry are passing in a different way, since it's a non-planar alene molecule, it's a non-planar. So one, it will be through through z axis, another through x axis, another through y axis. If they are passed, then we get the indistinguishable configuration. So if C2 is done in a horizontal way, passing through 3 carbon atoms, and if it is rotated in a clockwise direction, this gets shifted, this gets shifted, like that, these two get shifted. Then if the axis is passing in x-axis, then this and this gets flipped, this and this gets flipped, so like that. Similarly C2 also in just perpendicular, okay, to this axis, if it is then it gets flipped. So on rotation it gets rotated and it comes to this position. So these two gets the position of these two. So like that. So there are three different twofold axis of symmetries are possible. So they are listed C2, C2 prime and C2 double prime.